talk about the heat that is added or taken away during phase changes. Now, let's just look at water. Water has three phases. All matter has three phases. Ice is the solid phase, water is the liquid phase, and then water vapor is the gaseous phase. So if we start with ice and we add heat, we go from solid to liquid. Now, when we add heat, remember Q is mc delta T. And we've always got a temperature change. Now, as we go from water to water vapor and we add heat, this again is mc delta T. Now, these C's are not the same. They're different. Remember I told you that the CP we had depended upon the state, but we weren't going to worry about that. I'll always give the correct C. Now, what if we start back up here with water vapor and we release heat, then the vapor becomes a liquid, and the formula for the heat lost is Q is mc delta T, same formula. And of course, if you go from water to solid and we take heat away, heat lost is mc delta T. These are the same formulas. Of course, heat loss is going to be negative, heat gained is going to be positive. But something is happening in these regions right here when it's a vapor, when it's a liquid, and when it's a solid, when there's no temperature change. Let's look at a graph of, let's just do water. This works for every solid, every substance. Let's see, let's do ice. We know ice becomes a solid at 0 Celsius. And we know it vaporizes or turns to a gas at 100 Celsius. Now, below 100 Celsius, you can change the temperature. And right now it is ice. So I'm going to write ice right here. And I know the heat to change the temperature of ice is mc for ice times delta T. And ice has a specific heat. What about from 0 to 100 degrees when you've got water as a liquid? Okay, then the heat to do this changes is mc for water delta T. And similarly, once you hit the boiling point, the heat to change here is mc delta T, where all of these C's are different, depends upon the state. Now, what happens between this point and this point? All right, at this point right here, you see the temperature is the same. If I have ice and water, they're at the same temperature. They're at 0 Celsius, but I'm adding heat to change it from a solid to a liquid, or I'm removing heat to take it from a liquid to a solid. And this formula is very simple. It's the mass of your material times, and we're going to use the delta H of fusion. This is the latent heat of fusion. We'll discuss this more in a second. Now, what about this right here, from the time it's a liquid until it starts vaporizing? Okay, this is when you have condensation and vaporization. It's condensing when it's going from a gas to a liquid, and it's vaporizing from a liquid to a gas. The heat to do the vaporization is m delta H. Are you ready for this? Vaporization. I'm not going to spell this all out every time. I'll probably just use a lowercase v. Now let's see. So if I add heat to a solid, I get a liquid. If I lose heat from a liquid, I get a solid. All right, liquid to solid, solid to liquid. You'll see words like melting and freezing. That's how you know that you're at the liquid to solid part of the graph. Now, it doesn't matter whether you're going from liquid to solid or solid to liquid, the formula is the same. To heat, the heat to freeze or to melt is going to be Q is m delta heat of fusion. And this right here is always given to you. It's always a number. And we have to tell you what it is, or you have to find it. Q is a heat, loss or gain. M is a mass. And delta H is your latent heat of fusion. And latent, I always throw in that latent there. Some books just call it heat of fusion. Now, if you add heat to a liquid, you get a gas. Similarly, if you lose heat from a gas, you get a liquid. Now, the phrases you're going to be looking for this one are vaporizing or condensing. Vaporizing, of course, is becoming a gas, and condensing is becoming a liquid. And the formula, shockingly, is exactly the same as for fusion. Q is M, delta H, vaporization. Again, I'm not going to write this out every time. I'm just going to do HV. Q is M, delta HV, where Q is a heat, M is a mass, and delta H is a latent heat of vaporization.